is going to tell us about a better battery now. We're told that there's sodium metal and there's sodium ion.
While Elon Musk tweeted about Mars, his biggest nightmare quietly unfolded 7,000 miles away. BYD just bet $1.4 billion on something that could make every lithium mine worthless overnight. We're not talking incremental battery improvements. We're talking complete obliteration of Tesla's foundation. The shocking truth? Table salt. Yes, the sodium in your kitchen shaker is about to trigger the biggest industrial disruption since the internet destroyed newspapers. Chinese drivers are already buying sodium-powered cars today, while Americans wait for affordable EVs. Tesla's trillion-dollar empire might crumble in 5 years. The quiet revolution nobody saw coming. While everyone was obsessing over Tesla's latest software update and arguing about charging speeds, BYD was quietly cooking up something that could flip the entire EV industry upside down. We're talking about sodium-ion batteries. And before you roll your eyes thinking, oh great, another battery breakthrough that'll never happen, hear me out. This isn't some lab experiment or startup pipe dream. BYD, the world's largest EV manufacturer, just broke ground on a massive 30 gigawatt-hour sodium-ion battery plant in Suzhou, China. They're investing $1.4 billion into this facility. You don't drop that kind of cash unless you're absolutely certain you're onto something game-changing. But here's where it gets interesting and scary for established players. Sodium is literally everywhere. It's the 6th most abundant element on Earth. We're talking about using the same stuff that's in your kitchen salt shaker to power cars. Meanwhile, lithium? That's a rare, expensive metal that requires environmentally destructive mining operations in remote corners of the world. Think about it this way. It's like the entire EV industry has been building its empire on diamonds, and BYD just figured out how to make jewelry from sand that looks just as good and costs a fraction of the price. Right now, the battery pack is the most expensive part of any electric vehicle, sometimes accounting for 30 to 40% of the total cost. It's like trying to sell a house where the foundation costs more than everything else combined. That's the reason why Ford's executives probably aren't sleeping well these days. BYD claims its sodium-ion batteries will match the price of lithium iron phosphate batteries by 2025. But here's the kicker. Sodium is about 1,000 times more abundant than lithium. When supply goes up and demand stays the same, what happens to prices? They plummet. Imagine walking into a car dealership where the electric vehicle costs the same as a gasoline car, not because of government subsidies or manufacturer losses, but the battery genuinely costs that little to make. That's the nightmare scenario keeping traditional automakers awake at night. But wait, there's more. Remember how your phone dies faster in winter? Lithium-ion batteries hate cold weather. They can lose up to 40% of their range when temperatures drop. Sodium-ion batteries? They actually perform better in cold temperatures. So while your neighbor's Tesla is struggling to start on a frigid morning, your sodium-powered EV is purring like a kitten. And about charging speed, BYD has hinted that its sodium-ion batteries can charge incredibly fast, potentially matching or exceeding lithium-ion performance. Imagine pulling up to a charging station and getting 80% battery in the time it takes to grab a coffee and use the restroom. Here's something the lithium industry doesn't advertise on its glossy brochures. Lithium mining is an environmental disaster. Most lithium comes from salt flats in South America or hard rock mining in Australia. The process requires massive amounts of water. We're talking about 500,000 gallons of water to produce just 1 ton of lithium. In Chile's Atacama Desert, lithium mining has consumed so much water that local communities are struggling with water shortages. Flamingo populations are declining because their habitat is literally drying up. This is the hidden cost of our clean electric vehicles. Sodium mining? It's basically like harvesting seawater. The environmental impact is minimal, and there's enough sodium in our oceans to power electric vehicles for literally millions of years. But here's where it gets really interesting from a geopolitical perspective. China controls about 60% of the world's lithium processing capacity. Most lithium mines are concentrated in just a few countries, This creates supply chain vulnerabilities that we've already seen play out with computer chips and other critical materials. Sodium completely flips this script. Every country with access to seawater, which is basically every country with a coastline, can produce sodium. It's like going from being dependent on foreign oil to having an unlimited supply in your backyard. The technical reality check. Now, before we crown sodium-ion as the king of batteries, let's be honest about the challenges. The biggest elephant in the room is energy density. Lithium-ion batteries can pack more energy into the same space. It's like comparing a compact sports car to a pickup truck. They both get you there, but one takes up more room. Current sodium-ion batteries have about 70 to 80% of the energy density of lithium-ion batteries. For most people driving around town, this isn't a deal breaker. Your daily commute doesn't change whether your car has a 250-mile range or a 200-mile range. But for long-distance trucking or aviation, that difference matters. However, and this is crucial, battery technology improves rapidly. 10 years ago, electric vehicles had half the range they do today. BYD and other companies are working on second and third generation sodium-ion batteries that could close this energy density gap significantly. The real question is whether they're good enough for most applications while being dramatically cheaper and more sustainable. And for millions of urban commuters and delivery vehicles, the answer is probably yes. Here's where things get really wild. If sodium-ion batteries become mainstream, it doesn't just affect car companies. It creates a domino effect that reshapes entire industries. Tesla's entire business model is built on having the best battery technology. Their gigafactories, their energy storage business, their competitive moat. It all depends on lithium-ion supremacy. If a cheaper, more sustainable alternative emerges, what happens to Tesla's trillion-dollar valuation? Mining companies that have invested billions in lithium extraction could see their assets become worthless overnight. It's like what happened to Kodak when digital photography took over, except we're talking about companies worth tens of billions of dollars. But it's not just about existing players losing out. Sodium-ion batteries could enable entirely new business models. Imagine electric vehicles so cheap that ride-sharing companies replace their entire fleets within 5 years. Or developing countries that couldn't afford lithium-ion technology suddenly having access to clean transportation. The grid storage market could explode. Right now, storing renewable energy is expensive because lithium-ion batteries cost too much for large-scale applications. Cheap sodium-ion batteries could make solar and wind power practical everywhere, potentially accelerating the end of fossil fuels. What the experts are really saying. Industry insiders are split on sodium-ion batteries, and their reactions tell us everything we need to know about the stakes involved. Some lithium battery manufacturers are downplaying sodium-ion technology, calling it niche or suitable only for low-end applications. That's corporate speak for, we're terrified but don't want to admit it. Meanwhile, CATL, the world's largest battery manufacturer, is also diving headfirst into sodium-ion technology. They're planning to put second-generation sodium-ion batteries into production by 2025. When the biggest players in the industry are hedging their bets, you know something significant is happening. The Chinese government has identified sodium-ion batteries as a strategic priority. They're providing funding and policy support to accelerate development. This is about energy independence and technological sovereignty. But here's what's really interesting. Some experts believe we're not looking at an either-or situation. The future might be hybrid battery packs that use lithium-ion for energy density and sodium-ion for power delivery and cost-effectiveness. Imagine a car battery that gives you the best of both worlds. BYD's sodium-ion facility is expected to start production in 2025. By 2026, we could see the first mass-market vehicles rolling off assembly lines with sodium-ion battery packs. But here's the really crazy part. BYD already has vehicles in testing with sodium-ion batteries. The BYD Seagull, their ultra-affordable compact EV, was rumored to be getting sodium-ion batteries before they ultimately went with lithium iron phosphate. Industry insiders suggest this was a strategic decision to test the market reaction and production capabilities. If sodium-ion batteries prove successful in budget vehicles, the technology will quickly move upmarket. It's the same pattern we saw with electric vehicles themselves. They started as expensive toys for early adopters and gradually became mainstream. The timeline for widespread adoption could be surprisingly fast. In China, 2 compact electric cars already went into production with sodium-ion batteries in 2024. These aren't concept cars or limited productions. You can buy them today. The global implications. The shift to sodium-ion batteries could reshape global power dynamics in ways we're just beginning to understand. Countries that currently have no role in the battery supply chain could suddenly become major players. Any nation with a coastline could theoretically become energy independent. This could be particularly transformative for Africa and South America. Instead of shipping raw materials to China and buying back finished batteries, these continents could develop their own battery manufacturing industries using locally available sodium. The environmental implications are staggering. If sodium-ion batteries enable cheaper electric vehicles and grid storage, the transition away from fossil fuels could accelerate dramatically. But there's a darker side to consider. The current lithium supply chain employs millions of people worldwide. Mining communities, processing facilities, and entire regional economies built around lithium could face severe disruption. The transition to sodium-ion won't be painless for everyone. Smart money is already moving. While retail investors are still debating Tesla versus traditional automakers, institutional investors are quietly positioning themselves for the sodium-ion revolution. Venture capital firms are pouring money into sodium-ion startups. Patent filings for sodium-ion technology have exploded over the past 2 years. The companies that control key sodium-ion patents could become incredibly valuable very quickly. But here's the really interesting part. Some of the biggest winners might not be battery companies at all. Companies that manufacture sodium, water treatment technologies, and even salt production could see unexpected windfalls. On the flip side, lithium mining stocks could face a reckoning. Investors who thought they were buying into the future of energy storage might find themselves holding shares in the next coal industry. The automotive supply chain could see massive disruption. Companies that have invested heavily in lithium-ion manufacturing might need to completely retool their facilities. That's expensive, time-consuming, and not all companies will survive the transition. The safety revolution. Nobody's talking about. Here's something that could completely change how we think about electric vehicles. Sodium-ion batteries are inherently safer than lithium-ion batteries. Remember those scary news stories about Tesla cars catching fire or phone batteries exploding? That's thermal runaway, a dangerous chain reaction that can happen with lithium-ion batteries. Sodium-ion batteries operate at lower voltages and are much more chemically stable. They don't contain cobalt or nickel, 2 elements that can create toxic gases when they burn. If a sodium-ion battery is damaged in an accident, it's far less likely to catch fire or explode. This is good news for drivers and a game changer for insurance companies, emergency responders, and anyone who lives near where electric vehicles are parked or charged. Imagine fire departments not having to worry about toxic battery fires that can burn for hours and reignite days later. For shipping and transportation, this could eliminate many of the current restrictions on moving large battery packs. Airlines and shipping companies have strict rules about lithium-ion batteries because of fire risk. Sodium-ion batteries could make it much easier and cheaper to transport battery packs around the world. The safety advantages extend to manufacturing too. Lithium-ion battery factories require extensive safety systems and specialized fire suppression equipment. Sodium-ion facilities could operate with simpler, less expensive safety protocols. The recycling nightmare lithium created. Let's talk about something the EV industry doesn't want you thinking about. What happens to batteries when they die? Right now, recycling lithium-ion batteries is expensive, complicated, and often not economically viable. The process involves dangerous chemicals, high temperatures, and specialized facilities. Many lithium-ion batteries end up in landfills, despite containing valuable materials, because the cost of recycling exceeds the value of recovered materials. Sodium-ion batteries flip this equation entirely. Sodium is cheap and abundant, so there's less economic pressure to recover it. But here's the beautiful part. Sodium-ion batteries are much easier to recycle. The process is simpler, safer, and uses common industrial chemicals rather than exotic solvents. This means we could actually achieve true circular economy principles with electric vehicle batteries. Instead of creating a massive waste stream, sodium-ion batteries could be recycled indefinitely with minimal environmental impact. But here's where it gets really interesting. Some sodium-ion battery designs can be completely disassembled and rebuilt. Imagine taking your old car battery to a shop where they replace just the worn-out components rather than throwing away the entire pack. That's potentially possible with modular sodium-ion designs. The switch to sodium-ion batteries could completely transform the charging infrastructure landscape. Right now, DC fast charging is expensive, partly because of the sophisticated battery management systems required for lithium-ion batteries. Sodium-ion batteries are more tolerant of different charging conditions and don't require the same precise temperature and voltage control. This could make charging stations simpler and cheaper to build and operate. But here's the really wild possibility. Sodium-ion batteries might enable ultra-fast charging that would make today's fast chargers look painfully slow. Some researchers are working on sodium-ion designs that could charge from empty to 80% in under 5 minutes. Imagine pulling into a charging station and filling up your car's battery faster than it takes to fill a gas tank. That would eliminate range anxiety overnight and make electric vehicles more convenient than gasoline cars. The grid implications are massive too. If millions of vehicles can charge quickly without stressing the electrical grid, it changes how we think about energy infrastructure. Cities wouldn't need to massively upgrade their electrical systems to support widespread EV adoption. Home charging could become simpler as well. Sodium-ion batteries might not require the expensive Level 2 charging equipment that many lithium-ion vehicles need. Standard household outlets could potentially provide adequate charging speeds for daily use. Here's a perspective that's often overlooked. Sodium-ion batteries could be absolutely transformative for developing countries. Right now, electric vehicles are luxury items in most of the world because lithium-ion batteries are simply too expensive. Nigeria has 200 million people, but sells fewer electric vehicles in a year than Tesla sells in a single day. It's not because Nigerians don't want clean transportation, it's because they can't afford it. Sodium-ion batteries could change this completely. If BYD's cost projections prove accurate, we could see electric vehicles that cost the same as basic gasoline cars. For countries importing expensive petroleum, this represents potential energy independence. The manufacturing opportunity is enormous too. Countries like Bangladesh, Vietnam, or Mexico could potentially build sodium-ion battery factories using locally available materials and become major players in the global battery market. Think about the environmental impact. If cheap sodium-ion batteries enable widespread electric vehicle adoption in Asia and Africa, we could see a massive acceleration in global emissions reduction. The climate benefits could be far greater than anything happening in wealthy countries. But there's an infrastructure angle too. Many developing countries have unreliable electrical grids. Sodium-ion batteries could enable distributed energy storage systems that make renewable energy practical even in areas with poor grid infrastructure. The hidden technologies breakthrough While everyone's focused on the basic sodium-ion chemistry, there are some absolutely mind-blowing technological developments happening behind the scenes that could make these batteries even more revolutionary. Researchers are working on solid-state sodium-ion batteries that could have energy densities approaching lithium-ion while maintaining all the cost and safety advantages. If successful, this would eliminate the last major disadvantage of sodium-ion technology. There's also development work on sodium-sulfur batteries for grid storage applications. These could store massive amounts of energy at incredibly low costs, making renewable energy storage practical at unprecedented scales. Some companies are exploring sodium glass batteries that could last for hundreds of thousands of charge cycles. Imagine a car battery that outlasts the vehicle itself and could be transferred to a new car when you upgrade. The manufacturing innovations are equally exciting. New production techniques could enable sodium-ion batteries to be manufactured using existing lithium-ion production lines with minimal modification. This could accelerate adoption by eliminating the need for entirely new factories. There are even experimental designs for sodium-air batteries that could theoretically achieve energy densities higher than gasoline. While still in early research phases, the potential applications for aviation and long-haul trucking could be game-changing. The sodium-ion battery revolution is happening against the backdrop of a massive geopolitical shift in technology and energy. China's dominance in lithium-ion battery production has made many countries uncomfortable about their dependence on Chinese technology. Sodium-ion batteries could either reinforce Chinese dominance or completely reshape the global balance of power. BYD and CATL are leading sodium-ion development, which could extend Chinese control over next-generation battery technology. But here's the twist. Because sodium is abundant everywhere, other countries have an opportunity to develop independent battery industries. The United States, Europe, and other regions could potentially achieve battery independence using sodium-ion technology. The timing is particularly interesting given recent tensions over technology transfer and supply chain security. Countries that have been trying to reduce dependence on Chinese lithium-ion batteries might find themselves even more dependent on Chinese sodium-ion technology. Military applications add another layer of complexity. Electric military vehicles powered by sodium-ion batteries could operate in extreme environments where lithium-ion batteries fail. The strategic implications of this technology extend far beyond civilian transportation. Trade relationships could shift dramatically too. Countries that currently export lithium could see their strategic importance diminish, while nations with advanced chemical processing capabilities could become more valuable partners. So what does all this mean for regular people who just want to buy a reliable, affordable electric vehicle? In the short term, probably not much. The cars you can buy today will still use lithium-ion batteries, but within 5 years, you might have access to electric vehicles that cost significantly less while offering similar or better performance. For current EV owners, this could actually be good news. As sodium-ion technology matures, it could drive down the cost of replacement batteries and make electric vehicles more practical for secondary markets. If you're thinking about buying an electric vehicle in the next few years, it might be worth waiting to see how sodium-ion technology develops. Or, if you can't wait, consider that early lithium-ion vehicles will likely hold their value better than late-generation ones if sodium-ion becomes dominant. For investors, this represents both opportunity and risk. The companies that successfully navigate the transition to sodium-ion could see explosive growth, but established players that cling too tightly to lithium-ion technology could find themselves obsolete. Parents thinking about what car to buy for teenagers in a few years might want to consider that sodium-ion vehicles could be significantly safer and cheaper to operate than current options. Alright, so that's it for this video. And if you want to watch more amazing content like this, check out some of our other videos. Bye!